In this video, I will go over queues, like what are queues, when do we use them, as well as how do you use them, and some practice using queue operations in C++. Queues are data structures, or ADTs, and they're just like queues in real life. They follow the first in, first out behavior. So they're useful when we have a list of actions to do in order. For example, let's say we have a coffee shop queue. This is what a real life queue example. And we have the POS here. If we have 3 customers, this customer came in first and is going to be served first. So first in, first out, and then the second customer is going to come up, and so on. We cannot serve them all at the same time. For this reason, we also use queues in software and technology. And an example for that is a printer. Let's say you have multiple documents that you want to print. You could push those documents into a queue. So what the printer does is put these documents and then print each one of them at a time, because the printer cannot print them all together. So it follows this queue behavior, first in, first out, to execute this action. So again, it's a list of actions that we're able to do in order using queues. And this is what a queue looks like, using different terms that you might see. On the left here, this is the front, also called head. And then we have the back, also called tail or rear. Elements are inserted from the back and removed or popped out from the front. We enqueue elements or insert, and we pop or dequeue. So when do we use queues? To answer that, let's look at the queue operations that we have in C++. We have push, which allows us to insert elements from the back. It takes in one argument, which is the element, and it takes big O of 1, which is constant time. Remove pops the last element, which happens to be at the front and is also constant time. And then we have empty and size, which give us information about the queue, whether it's empty, how big it is. And then we have front and back, which allows us to access the elements at the front and the back of the queue. They're also take constant time. As you can see, all these operations involve either the beginning or the end of the queue. We don't really access or work with the middle of the queue unless we traverse it to see what the elements we have. So queues are basically useful when we have a set order of elements that we want to take action on. For example, we don't want to change the order after we insert an element into the queue, because that would involve accessing the middle of the queue, which would not be efficient. So once an element is inserted, that first element is gonna come out first, and so on. And queues, they're useful when we want to use the first in, first out behavior, because unlike decks, which are double-ended queues, decks allow us to insert elements at the front and the back of the queue. So if we had like an element that's at the front of the queue, we could insert another element after it, but that doesn't follow the first in, first out behavior, because that last element was inserted last and will come out first. So this is how double-ended queues are different from queues, which are implemented using them, by the way. So queues are implemented using DEX in the STL standard template library in C++. And then this is how we use queues. Basically, we include the queue library, and then we use the queue keyword with the type of the queue and the name. And we use the operations we saw here to insert elements into the queue. So here we inserted, say we have this front, we have back. So once we insert one into the queue, it becomes at the back of the queue. And then once the second line runs, we have 3 at the back, and then 1 moves up to the front until we add the rest of the elements. So we have 1, 3, 5, 7. And then pop removes the element at the front, which is the first one that was inserted. So that's why it's first in, first out. Now 1 is popped and 3 becomes at the front. So nums.front would allow us to access the element at the front, which is 3. Back is 7. The size is 3, and empty is just 0, because it's 0 if it's not empty, which is false. 0 if it's empty, which means false, and not 0 or 1, which means true, that it's empty. And here's some practice of what the code looks like. This is the same example. We push 1 in first, so 1 goes from the back to the front. So we have 1, 3, 5, and 7, as you can see here. We pop 1, and then the front becomes 3. The back is 7, because it's the last one to be inserted. The size is 3. Empty is 0. And we could traverse the queue by using a while loop. So we iterate as long as the queue is not empty, and we print out the front. So if we had 3, 5, and 7, the front is 3. After we print it, we pop it, so we move on to 5. 5 is the front, and 7. And this is how you access the elements in the queue, by traversing